We're solving problem 19 from the 2022 F equals MA exam B. Where we have this rod on two springs with spring constant K, and the rod has mass M and length L. The rod is brought back into equilibrium after it's pressed down. That doesn't matter. It is slightly rotated about its center of mass and then released from rest. What is the frequency F of its oscillations? So it's in this case it's tilted where you press down on one side and say there's a change in angle delta theta. So it's like sort of bouncing up and down like tilting. So if it's rotating, first in this case we want to find the torque. So the torque of this body is T equals -2 times the force of the spring times the length divided by 2 for one spring. This is for one spring. We can calculate the force of the spring. So we can equate it down here. This is -2 times one of the spring constants K, L over 2 times delta theta. And then you have to multiply this L over 2 on the outside. These twos cancel out. And then it's just algebra, or in this case just find a simple equation for the torque. We get that the torque is equal to KL squared, change in theta, over 2, and take that negative. So this is our equation for torque. Now, like in problem 18, we want to use Newton's second law, but in this case we use a variation of it where we're using the rotational form, because in this case it's sort of rotating around a point there. So if we have this Newton's law, and this is the force, by the way, or not the force, but we can equate it to the torque because that's Newton's rotational second law. Negative KL squared, we can just say theta for this and then divide by 2. So to isolate this variabilitic theta, I don't think that's a word, but we isolate this and then divide both sides by the I, is KL squared theta over 2I. Well, now, much like the previous problem, we notice that this is sort of like the form rotational for omega, for our omega in this case, which in the last case we were dealing with up and down springs, which is more straightforward. That's square root 2k over m. In this case, we have an omega, which is KL squared over I. So, this is going to be a lot more complicated to find out, but we can actually substitute a value for I. Because we want to consider this rod, or I, or inertia, is m times the length squared divided by 2. Or not 2. It would be divided by 12. But since we are not, this is the full rod and we're not considering that, we plug half of that in there. So omega is equal to the square root of KL squared over ML squared over 6. These L's cancel out, and what do you get? This simplifies to square root of 6k over m. So we have found omega. Now we can only just plug it into the frequency, or how to find the frequency, where the frequency is omega over 2 pi. You can just substitute this omega value in. 1 over 2 pi times 6k over m is our answer for this problem for the frequency of this rod moving.